Hello, hello. Today we have a problem they have been given to us, which is vectors that we have for this equation. Sorry for me. Like, we get a vector E, vector D, vector F, and they give us the angle with angle of the vector D with the x hat, which is 24. And you can see we have a z hat. The z hat is not shown, so that means z hat is 0, which that circle over there. You have an x hat, which is goes towards the right in the standard form. Right on the standard form where my mouse is pointing at, and then we have the y hat, which is also standard of going up. We're gonna use these to identify the components of these vectors. That we have a magnitude, we have a vector d 2.73, vector e 3, and vector f 1.77. Now let's go to components. D goes towards the right, so we're gonna use the standard x goes to right 2.5 times to get to the x components of d, and then we go one up to get one vector of y to get the standard y. For e, we are going towards left, so it's going to be negative 2.5 is the same distance of d. The only difference is we're going 1.5 instead of 1. For vector f, we're going 1 left, 1 down. It's going to be negative 1x, negative 1y. Now they told us to find the components, and for components we can find x equals 2.5 that we had for the first one for the d, then plus negative 2.5, which is the e1. They're going to cancel each other out, and then you get negative 1 from the f1, which gives a negative 1 x component for the resultant. Y is going to have 1 plus 1, negative 1, which they're going to cancel each other out, and then you're going to 1.5 and get 1.5 y hat, y component. Z, why is Z has all 0? Because we didn't even have a Z hat for any of them. So if you don't have anything, that's 0. So we're going to add just 0 and then get 0 as a result of Z hat. So the resultant vector, which is going to be R, we can call this Robin, it's going to be negative 1 for the x component, 1.50. We're going to use that standard that we talked about again. We're going to use the y hat and x hat, and then we use z hat, and then we're going to draw that negative 1 and then the 1.5, 1.5 to get R. Over here, we're going to have these drawn out. So if we draw D and then E and then F, we get this resultant vector, which is S this time, to get around. Now for this one, I decided to do the angles right over there so we can have the angles on for dot product. We have been given that D has a 24 angle, and in one of the videos that we did, we find out if you have 24 plus 66, we're going to get 90 degrees. So this is a 90 degrees angle. We're going to get 66 over here. We're going to move up, and we get a 24, because if that is the triangle that we have, and then 66, again, we proved 24 and 66 is 90, so they're going to be 24. And then 60, since that is a 90 degrees angle, that's going to give us a 30 degrees over here. Add them up, and we get the vector between E and D, 54 degrees. We're going to go up. If you have 30, 90 degrees and 60 over here has to be, because we proved it already. So there you have the 60 degrees. We get 135 minus it by 90, and we get 45 degrees. So 45 degrees here. If it's 45 and then we have 90 degrees angle, we're going to have 45 for the rest of it. Add them up, and we get E and F 105 degrees. If you have 45 and 90, we're going to get 45 over here. That's pretty much sure. Now for this one, we can use a rule that we have in algebra and geometry and say, okay, if you have a line like this, coming like that, and line like that, the angles in front of each other are supposed to be same. If they're supposed to be same, you're going to get 24 degrees. Now if you have 90 here, this is supposed to be 66, that's for sure. So you have 90. If you have 90, if you look closely, this seems to be another 90 over here. So you get 24 over here, and then you get 90 degrees. If you have 24, 90, again, what the angle is going to be a 66. Again, so 60 plus 45, 111, 40 degrees. So you can have our angles cleared up. Now we're gonna go and do the dot product. We're gonna get vector E and F, and we're gonna have our numbers that we have. We're gonna find out that S has 1.80 because it has a very low amount after the F, so it's gonna be 180 for that kind of vector. So we can have the angles on. We're gonna get, multiplying them by the magnitude, get the cosine of the angle. Remember, E and F had obtuse angle, so you're gonna have a negative. Same for F and S. We had an obtuse angle, you're gonna get a negative one. Now we have a acute angle for F and that's not F and F. That's D and E. My problem. That's the problem I did. This D and E, you're gonna have D and E, which is gonna be 2.73 times 3 to cosine of 54. We're gonna get a positive 4.81. And then we have this, and again, it's not F and F. This is S and D. I made a mistake over there. Oh, what happened? Okay. I'm gonna come back to that once again. All right. Then we have 1.80 times 2.73. Oh, we have a cosine of 90. That's 0. So times 0, we get 0 for dot product. Hopefully you guys enjoyed, and see you guys in the next videos.